Okay, class. So this is the chapter 2.8. This is the last section of the proof section. Like I said, we are not going to have an exam on this. I will most likely just put a little quiz or something else alongside unit 3, which is also very short. For this video, there's not much for me to go over. All I'm going to do in this video is just kind of read the different theorems to you and kind of review with you guys. But for the most part, this is all stuff that we've seen before, such as like definition of complementary angles, definition of supplementary angles, and so on. This is all things that you've seen before. So just as a review, right, we have our properties of equality. This was our section 2.6. All the addition property, subtraction, multiplication, and division property says is that, hey, you can do that operation to both sides of the equal sign, and that's what it is. So for the addition property, if you add the same number to both sides, you're good to go. Subtraction property, subtract from both sides, good to go. Division, multiplication, same thing. We have the distributive property, right? This is saying, hey, if you have something on the outside and there's a parentheses, you're just going to distribute, or you're going to FOIL that A term into the two terms inside the parentheses. Substitution property. This is just saying, hey, if I know that 4x plus 2 is the equation that's given to us, and we know that x is equal to 1, well, instead of saying 4x plus 2, we can substitute that x is equal to 1 here, and this will just be 4 times 1 plus 2. This is your substitution property in effect. Following that, we have a reflexive property. This just says that, you know, something is equal to itself, which is very obvious. So 10 is equal to 10, x is equal to x, something is equal to itself. Following that, symmetric property, all this is saying is if we have something like this, A is equal to B, then B is equal to A. Last thing, we have the transitive property. What this tells us is that if we have A is equal to B, and we know that B is equal to C, then A is going to be equal to C. They are all connected to another. Think about the dollar is equal to 4 quarters. 4 quarters is equal to 10 dimes, which means that that dollar is equal to 10 dimes as well. So those are your properties of equality. If you guys have any more questions, feel free to email me, or you can ask your neighbors. Yeah, you guys can work together on today's assignments. Following that, we have our properties of congruence. This, right, our 3 properties over here are the exact same thing as the properties of equality over here, except that instead of a equal sign, we're just going to have a congruent sign. Yeah, all 3 of them, congruent sign. Okay. Moving on, we have our definitions, right? Definition of congruence. That says if and only if segment AB is congruent to segment CD, then we can say that segment AB is equal to segment CD. And it can also go the opposite way around as well, right? If we have something that's equal to one another, you can say that they are congruent. That's your definition of congruence. Following that, we have definition of midpoint. So definition of midpoint says, hey, if we have this line segment, and this is our midpoint, A and C are our endpoints. Well, this tells us that, hey, if M is our midpoint, AM is equal to MC. So the lengths of our line segments are equal to one another. Last one, definition of a right angle. I don't think we went over this one last time, but basically definition of a right angle, right? Right angle is something that looks like this. Yeah, and we all know that a right angle is 90 degrees. So that's what you need to know. Okay, moving on. So you guys can be taking down these notes if you guys need these reviews. But I mean, like I said, this is just a review, so you don't need to copy down if you don't want to. Following that, we have our definition of a complementary angle. We know that a complementary angle is equal to 90 degrees. That's what it says here in our definition. Right? It says, hey, if angle 1 plus angle 2 is equal to 90, then angle 1 and angle 2 are complementary. So an example of a complementary angle, right? This is angle A. This is angle B. If angle A is 47 degrees, angle B is 43 degrees, right? If we add angle A plus angle B, this should be equal to 90 degrees if it is complementary. 47 degrees plus 43 is 90, so that means that these two angles are complementary. Okay. Moving on, supplementary, same idea, right? But now it's equal to 180 degrees. So 180 degrees is a straight line. This entire angle right here is 180 degrees. If we cut this angle, right, like this and this is angle B, this is angle A, and we say that angle A is equal to 120 degrees. Well, angle B must be 60 degrees, right? In order for angle A plus angle B to be equal to 180. That's how we make our supplementary angle. So that's another definition that you guys can use to justify your statements. Lastly, definition of perpendicular. So remember, perpendicular just means that we have two lines crossing. So one line like this, and we have another line like this. When we have two lines intersecting with one another, they create right angles. So this is a right angle, this is a right angle, this is a right angle, and this is a right angle. So you have angle 1, angle 2, angle 3, and angle 4. Those are all right angles because we have a perpendicular. And those are two are perpendicular lines. So angle 1, angle 2, angle 3, and angle 4, they're all equal to 90 degrees because we have two perpendicular lines. That is your definition of perpendicular. And this is the notation that we use over here, right? That upside down T, that tells us that it's perpendicular. So this reads line M is perpendicular to line N. Moving on, congruent complement theorem. All this is saying is, hey, if J is complementary to K and L is complementary to K, then angle J is complementary to angle L. So this is kind of like your transitive property in effect. So our congruent complement theorem, it says angle J, I'm just going to put comp for complementary, it's comp to angle K, and angle L is complementary to angle K. Then angle J is congruent to angle L. So think about it like this, right? If A is equal to B, B is equal to C, then A is equal to C. Yeah. So this is like your transitive property in effect here. Okay. Moving on, congruent supplementary theorem, same idea. If A is complementary to B and A is complementary, if A is supplementary to B and A is supplementary to C, then angle A is supplementary to C as well. I believe this should be if A is equal to B, A is equal to C. I believe this should be angle B right here. Angle B should be supplementary to C. Because we already know that A is supplementary to C. So this should be B is equivalent to C. Okay. So supplementary theorem or congruent supplementary theorem. It states that if angle A is supplementary to angle B, and angle A is supplementary to angle C, then angle B is congruent to angle C. Yeah. So actually, I want to put some pictures for you guys. So using the first term, right? This is angle A. This is angle B. So this is this one right here. This one. And this is also angle A again, right? Angle A over here and angle A over here should be the same because they're both A. This is angle C. Right? Because we know that angle A over here and angle A over here, they're the same. That means that angle B and angle C should be the congruent to each other or equal. So that's what this supplementary theorem is saying. Yeah, angle B and angle C are the same. Same idea over here. Let me just go back to the complementary example for you guys. So if angle J, right, this is angle J, this is angle K. So if angle J and K are complementary, and we have angle L and angle K, right? We're K over here and K over here because they're both K, they're equal to each other. So their angles are the same. Then it means that this angle, angle J and angle L, they are congruent to one another, right? They should be. And those are your two congruent theorems. So congruent complement theorem and your congruent supplemental theorem. Afterwards, you have easy definitions, right? Vertical angles theorem basically just says that, hey, if we have two angles that are across from one another, then they are congruent to each other. So example, right? Your vertical angle theorem states if you have two angles across from one another, like for this example, this angle and this angle. And let's say that we know that angle A is 88 degrees. That means that angle B should also be 88 degrees because this is our vertical angle theorem. Yeah. Angle A is congruent to angle B because they are vertical angles. We also have the complement theorem. Basically, what this is saying is that if we're two angles form a right angle, then X and Y are complementary. So this one's very easy. Yeah. Try not to mistake this one with your congruent complementary theorem, because the congruent complement theorem is a completely different thing. Our complement theorem just says if angle X and angle y equal 90 degrees, then angle x and angle y are complementary. So angle x, angle y, and it forms a right angle, then these two are complementary. This angle and this angle are complementary. Same idea for the supplementary theorem, right? Supplementary theorem. If H and I form a linear pair, so remember linear pair, you guys can look back at your notes, but linear pair means that we have two angles that are adjacent, which means that they are touching one another. So this angle right here and this angle, they're touching each other. They're right next to each other by this line over here. And the two angles, right, angle A and angle B, they add up to 180 degrees. So the theorem just says, hey, if angle A and angle B form a linear pair, then A and B are supplementary, or they add up to 180 degrees, or equal to 180 degrees. Okay. Lastly, you just have your postulates, right? Segment addition postulate. So segment addition postulate. This says that if you have a line segment like this, we have A, we have B, we have C. This says that segment AB plus segment BC is equal to the whole thing. So once again, segment AB plus segment BC is equal to our entire line segment of AC. This is my segment addition postulate. Last thing on our notes for today and for this review is our angle addition postulate. So angle addition postulate. This just says, doesn't matter what type of angle you have. And let's label this A, B, C, D, right? This says that angle ABD or ABC plus angle CBD is going to be equal to our whole angle, which is ABC. So ABC, the entire angle. So angle ABC plus angle CBD is equal to our entire angle, which is angle AB. Okay, so those are all the notes and all the extra theorems and postulates that you guys can use. Of course, you guys can always use the things before, like the properties of equality, properties of congruence, and so on. I want you guys to work on this practice example right here. So all of these practices basically just justify the statement by telling me what properties, postulates, or theorems are being used. Afterwards, you guys have some practice problems. So 1, 2, 3, 4, and 5. And then you guys have your homework assignment. So homework assignment, Yeah, that'll be due all on Wednesday when I come back. Okay, so you guys have 2 days to work on this section. If you guys have any questions, please feel free to email me. Um, if not, work together with you guys' classmates, neighbors, and good luck, guys. I will see you guys back on Wednesday. Bye, everyone.